Where most people see waste or trash, some people see a well-intentioned life and a home. Across the world, builders are creating beautiful, livable spaces from materials most of us throw away. Tires, containers, salvaged wood, earth, glass, steel, hemp. And the results are changing the way we think about what a home can actually be. Here's something worth sitting with for a moment. The median cost to build a new home in the United States crossed $400,000 for the first time in 2023. Not to buy it, to build it, before land. Lumber, concrete, steel, drywall, every material in a conventional build is more expensive than it was 10 years ago. Some by 2 times, some by 3. Supply chain that feeds conventional construction is global, fragile, and increasingly expensive, and most of us just accept it as the only option. At the same time, the construction industry generates somewhere between 600 million and 1 billion tons of waste in the United States alone every single year. Lumber offcuts, concrete rubble, perfectly good bricks from demolished buildings, materials that took enormous energy to produce, used briefly, and buried. Nearly half of everything that ends up in American landfills came from building something, or from tearing it down. There's a growing community of builders, architects, and ordinary people who looked at both sides of that equation, the cost of new materials, and the waste of existing ones, and found a third path. Not going without, not roughing it, building better with what already exists. Today we're going through 10 home types that prove sustainable building isn't about sacrifice. It isn't about ideology. It's about looking at the material world differently and discovering that some of the most beautiful, durable, high-performing homes on Earth are built from the things most people walk past without a second look. Here's what's possible. Let's get into it. Number 1, the Earthship. The Earthship is one of the most radical rethinkings of what a home can be, and it starts with something you replace every few years and never think about again. Used tires. Each tire is packed with several hundred pounds of compacted soil, then stacked in offset rows like bricks and covered with plaster. The result is a wall so dense, so thermally massive, that it functions like a battery. It stores heat during the day and releases it slowly through the night. The wall works for you while you sleep. People build Earthships because they want to step out of the conventional systems entirely, not as a statement, as a practical decision. Most Earthships harvest their own rainwater from the roof, treat it through botanical cells inside the building, and recycle it multiple times before it leaves the structure. They generate electricity from solar and wind. They grow food inside the home year-round. It's not just a building, it's a complete living system contained in a single structure. The concept was developed by architect Michael Reynolds in New Mexico starting in the 1970s, and what began as a fringe experiment now has thousands of completed builds across 6 continents. The design has been refined over 5 decades of real-world testing. The thermal performance is the thing that surprises people most. Earthships in climates as extreme as the northern Scottish Highlands maintain a comfortable interior temperature year-round, with no conventional heating or cooling system. The walls do what a furnace and air conditioner would otherwise do. They just do it silently, for free, and for the life of the building. Here's the honest picture. Earthships are not fast to build. Packing each tire by hand is physically demanding, repetitive work. A full build can realistically take several years if you do it yourself, even with help. The learning curve on integrating the water, power, and food system adds another layer of complexity. This isn't a reason not to build one, it's the thing to plan for. Costs range from around $50,000 for a committed self-builder who sources their own tires and does most of the work themselves, to well over $300,000 for a professionally finished model with all systems integrated. Permitting varies significantly by county. Research your local codes before you buy land. But when it works, and it absolutely does work, there is nothing quite like standing inside a home built from tires and earth that heats itself, cools itself, waters itself, and powers itself from the sun. Nothing. Number 2, shipping container homes. More than 17 million shipping containers are sitting idle in the ports, storage yards, and empty lots around the world at any given moment. Each one is a pre-engineered steel structure designed to be stacked 6 high and survive storm conditions on the open ocean. They're built to take punishment, and you can buy a used one, structurally sound, weatherproof, already load tested for as little as $1,500. Architects and self-builders have discovered that these industrial boxes, precisely because of their rigid structural geometry, can be stacked, offset, cantilevered, and combined into homes of genuine architectural ambition. Open floor plans, rooftop terraces, full-height glass facades cut directly into the steel. Some of the most striking contemporary residential architecture being built anywhere in the world right now uses shipping containers as its primary structural element. In Joshua Tree, California, in Auckland, New Zealand, in Brighton, England, in rural Texas, the same industrial module transformed into something completely different in every location. Speed is one of the most compelling practical advantages. Framing a conventional home takes weeks or months. A container, a complete structural box, can be craned into final position in hours. The structural shell is essentially finished the moment it lands on the foundation. The steel is corrosion resistant and virtually indestructible. The modular system means you can start small, 1 or 2 containers, and expand as budget or family size grows. The thing that catches people off guard: insulation. Steel is an extremely efficient conductor of heat and cold. An uninsulated container in summer is an oven. In winter, it's a refrigerator. This is a solvable problem, but it needs to be budgeted and planned from the beginning and not retrofitted later. Also worth knowing, cutting large openings in container walls for windows and doors weakens the structural steel frame. This requires reinforcement, welding work, and that adds cost and needed skills for execution. A basic single container off-grid cabin can be completed by skilled self-builders for under $30,000. A multi-container architect-designed home with full finishes can run well over $200,000. Done right, the industrial aesthetic, the clean geometry, the sheer durability of the envelope, container homes produce some of the most architecturally striking residential spaces being built anywhere today. The material is a rectangle of weathered steel. What ends up inside is entirely up to the imagination. Number 3, straw bale homes. The first thing most people say when they hear straw bale homes, they must burn easily. The data says the opposite. When bales are compressed tightly and sealed inside lime or earth plaster, there's almost no oxygen available for combustion. The wall becomes dense enough to resist fire more effectively than standard framed construction. A properly plastered straw bale wall achieves a fire rating of up to 2 hours. A standard stud wall, 30 minutes. People build straw bale homes for the walls themselves. Those deep window sills, sometimes 18 inches or more across, where you can sit and read. The organic curves where the plaster follows the bales, the way light hits a lime-washed surface differently at every hour of the day. And the insulation performance. Straw bales regularly achieve R30 to R40. A standard 2x6 framed wall hits around R19 on a good day. What that difference means in practice? Heating and cooling loads drop substantially. In cold climates, a well-designed straw bale home can stay warm with a fraction of the fuel a conventional house requires. People who live in straw bale homes consistently report that the interior quality, the quiet, the temperature stability feels different from any other building they've lived in. The critical variable is moisture. Dry straw is excellent, wet straw will mold. Every great straw bale home is designed with this in mind from day one. Generous roof overhangs, solid foundations, vapor-permeable plasters. This isn't complicated, it's just non-negotiable. The bales themselves are cheap, $3 to $10 each. A modest home uses a few hundred bales. The investment goes into labor and finishing. Most U.S. states now have explicit straw bale provisions in their building codes. No stud-framed wall in any price range produces what a straw bale wall produces: the depth, the texture, the feeling that this structure has mass and permanence. It's built from a surplus agriculture material that would otherwise decompose in a field, and it outperforms conventional construction on nearly every thermal measure. Number 4, cob houses. Cob buildings in Devon, England are over 500 years old and still occupied today. Cob is one of humanity's oldest building traditions. A simple mixture of clay-rich subsoil, sand, and straw, worked together and applied in continuous masses, can take virtually any shape the builder can imagine. There are no bricks, no blocks, no straight lines required. Cob goes on wet and is sculpted as you go, which means walls can curve around a view, windows can have deep carved seals, walls can taper and swell. The building grows organically from the ground up. People build cob homes for reasons that are difficult to quantify from the outside. There's something about constructing a building with your own hands, from the earth directly beneath it, that produces a different relationship to the place you live in. The building isn't assembled from components made somewhere else by someone else. It grew here from this ground, shaped by these hands. Practically, the primary material is often free. In many cases, the soil excavated to dig the foundation contains enough clay to build the entire structure above it. The land funds the home. Cob is naturally fireproof. It doesn't burn. It's completely non-toxic. Its thermal mass moderates temperature swings naturally, and when it's kept dry, which is primarily a roof and foundation design question, it lasts essentially indefinitely. Here's the part cob enthusiasts don't always lead with. It's slow. Building by hand in layers with drying time between courses, a modest cob cottage can take a committed self-builder an entire season. Some people find this most satisfying, while some find it grueling. It's worth being honest with yourself about which one you are before you start. Material costs can be genuinely extraordinary, near zero for the structural material itself. What costs money is time, skilled finishing, and the roof, which in a cob construction is the single most important investment. A good roof is what separates a cob building that lasts 500 years from one that deteriorates in 20. Nothing manufactured at any price produces what a cob home produces. The rounded corners, the carved niches, the walls that have texture and depth and variation because they were shaped by human hands rather than cut by a machine. It looks like the ground grew up and became a house. Number 5, rammed earth. Take a moment and look at that wall. Those bands of color, gold, ochre gray, rust, cream, running through the wall in continuous horizontal layers. That's not stone veneer. That's not painted concrete. That's not manufactured at all. That's the earth from the site this building stands on, poured into forms in thin layers, compressed with pneumatic rams until it reaches stone-like density, then stripped to reveal what was always inside it. Every rammed earth wall is completely and irreducibly unique. The colors, the striations, the exact character of the surface. They're a direct record of the geology of the specific place it was built. Sections of the Great Wall of China are rammed earth. They've been standing for over 2,000 years. The Alhambra in Spain, fortifications across North Africa and the Middle East. This isn't an experimental technique. It's one of the most proven structural systems in human history, being rediscovered by contemporary architects who recognize what it can do. The thermal mass is extraordinary. A rammed earth wall absorbs solar heat through the day and releases it slowly overnight. A passive heating and cooling cycle that significantly reduces mechanical system load. The walls are fireproof, pest-proof, maintenance-free for the life of the building. They get harder over time as the earth continues to compact. And the acoustic quality inside a rammed earth structure, the quiet, is remarkable. Rammed earth is not a casual self-built project. The formwork, the mold system that contains the earth while it's being compacted, requires engineering and specialized construction knowledge. For most rammed earth builds, you're hiring a specialist contractor. Rammed earth sits at the higher end of natural building cost, primarily because of the framework, formwork, and labor involved. The counter-argument is durability. A well-built rammed earth home needs almost nothing done to it for the first 100 years. No repainting, no residing, no structural issues. When you amortize the cost of the life of the building, the economic shift considerably. In the best rammed earth architecture, the wall doesn't support the design, it is the design. The material is the most beautiful thing in the room, and it came from directly beneath the building. 5 homes in, all of them different, all of them built from materials that would otherwise be waste or earth or agricultural surplus. And here's the thing that keeps coming up across all of them. None of these homes feel like compromises. They feel like upgrades in thermal performance, in material quality, in the relationship between the building and the place it's built. The next 5 get into territory most people have never heard of, including, at number 10, a material that may be the most remarkable building substance we've ever had access to. So let's keep going. Number 6, reclaimed timber. Across rural America, thousands of old barns are slowly collapsing. They were built a century ago or more from timber that came from old-growth forest, trees that took 300 or 400 years to grow before anyone touched them. Those trees don't exist anymore. The forests they came from were cleared before anyone thought to protect them. The timber that was cut from them, that ended up in barns and factories and warehouses, is some of the densest, most dimensionally stable wood available anywhere on Earth. And a lot of it is sitting in buildings that are about to fall down. People build with reclaimed timber because the material carries something that can't be manufactured. The mortise and tenon joints cut by someone who's been dead for 100 years. The hand-hewn marks from broad axes, the patina, gray and silver and brown and gold, that develops over decades of exposure. New lumber at any price doesn't age like this. It just ages. Beyond the aesthetic, and the aesthetic alone is worth the conversation, this timber performs. Old-growth wood is significantly denser and harder than fast-grown modern lumber. It's dimensionally stable in ways that fresh-cut lumber never will be. It won't warp, twist, or shrink the way new wood does as it acclimates. Sourcing is everything here. Not all reclaimed timber is worth using. Some has been damaged by moisture or insects. Some was treated with lead paint or pesticides. Proper inspection before purchase is essential. Budget time to find the right material, not just any material. The range is enormous. A farmer who needs an old barn removed may give you the entire structure in exchange for the deconstruction labor. A premium dealer selling cleaned, kiln-dried, and certified reclaimed beams charges accordingly. There is no substitute for a room with genuine old-growth timber overhead. No reproduction, no engineered product, no new lumber at any price. Every knot, every grain line, every century of growth is still in there. You don't add that, you find it. Number 7, pallet wood. 2 billion wooden pallets move through the American economy right now. They carry everything: food, electronics, building supplies, furniture. Many are shipped to a single load and then left at the destination unwanted. Most of those pallets are made from genuine hardwood: oak, maple, cherry, pine, sturdy enough to carry several thousand pounds of freight. The boards are rough, character-filled, and often available for free from hardware stores, grocery distribution centers, and furniture warehouses that have no use for them. People build with pallet wood because the barrier to entry is almost zero. The material is free, it's everywhere, and once disassembled and cleaned up, those individual boards have a texture and grain quality that new dimensional lumber doesn't come close to matching. For interior cladding, accent walls, wide plank flooring, custom furniture, garden structures, small outbuildings and studios, pallet wood creates warmth and character in applications where new wood would just look flat. Now, this matters, and it's easy to miss. Not all pallets are safe for indoor use. Every pallet carries a stamp indicating how it was treated. HT means heat treated. The wood was sterilized with high temperature, no chemicals. That's safe to use indoors. MB means methyl bromide, a chemical fumigant that is not safe for enclosed living spaces. Check the stamp before you bring them inside every time. The material is frequently free. The investment is labor, sourcing, deconstructing, inspecting, prepping, and finishing. The texture, the variation, the way light plays differently across every single board, this is what manufactured products spend enormous effort trying to stimulate. Here, it's the original. Number 8, glass bottle walls. What you're looking at is a wall made entirely from reclaimed glass bottles, set into mortar or cob with their bases facing outward, their openings embedded in the wall. When sunlight hits the bases, each bottle acts as a small lens. The effect from inside is unlike anything a conventional window or wall can produce. Deep reds, cobalt blues, amber, emerald, colored light falling across interior patterns that change through the day as the sun moves. It's functional stained glass made from bottles. People build bottle walls because the material is everywhere and the visual result is extraordinary. Restaurants, bars, and hotels discard tens of thousands of bottles every week. One builder in Nevada sourced over 40,000 bottles from a single hotel's recycling stream to build his entire home. The structure cost him almost nothing in materials. 40,000 bottles, one home, zero material cost for the walls. Functionally, bottle walls provide real thermal mass. The glass absorbs heat during the day and releases it slowly. Structurally, when properly mortared, they're surprisingly robust, far more than you'd expect. Bottled walls are most often used as feature elements within a larger natural building project, an accent wall in a cob or earthship structure, rather than as the complete structural system of a building. Every photographer who walks into a room with a bottle wall takes 47 photos. Every time. Number 9. Adobe. Taos Pueblo in New Mexico has been continuously inhabited for over 1,000 years. The building standing there today is adobe. It has never been abandoned. Adobe is one of the oldest continuously practiced building traditions on Earth. Clay-rich soil mixed with sand and straw pressed into simple molds and sun-dried. No kiln, no factory, no manufactured inputs. The bricks are stacked with earthen mortar into walls of tremendous mass and deliberate beauty. Rounded at the corners, smoothed with plaster, warm in a way that modern materials don't produce. People build adobe homes because something about the atmosphere inside them is genuinely different from any other building type. The thermal mass is extreme. These walls are often 18 to 24 inches thick. Temperature swings that would register immediately in a lightweight structure simply don't penetrate. The result is a silence and stability inside the building that people describe as the closest thing to living in the earth itself. Adobe walls store heat during the day and release it slowly through the night. Passive temperature regulation that has kept people comfortable in some of the most extreme climates on Earth for thousands of years, without a single mechanical system. In the desert Southwest, an adobe home can stay 10 to 15 degrees cooler than outdoor temperature on the hottest days, without air conditioning. Adobe requires protection from sustained moisture and protective plaster coatings. In wet climates, an additional engineering is required. In the arid climates where adobe originated, it may be the most forgiving natural building method available. In many cases, the earth excavated for the foundation contains enough clay-rich soil to produce all the bricks needed for the structure. The land excavation funds the home. The primary investment is labor and time for the bricks to dry. At golden hour, a well-built adobe home doesn't just look warm. It glows from within, as if the heat it absorbed all day is finally visible. Number 10. Hempcrete. The last home type on this list is one most people have never encountered, and it may be the most remarkable building material currently available anywhere. Hempcrete is made from the woody inner core of the hemp plant, called the hurd, mixed with a lime-based binder and water. The result is a lightweight, fibrous composite material that can be cast into forms, sprayed onto structural frames, or compressed into blocks. It looks almost nothing like what you'd expect a wall to be made from. Hemp is one of the fastest-growing plants on Earth. During its rapid growth cycle, it sequesters significant amounts of atmospheric CO2 into its cellular structure. When that material becomes hempcrete, the carbon stays locked in the wall for the life of the building. Hempcrete doesn't just avoid carbon emissions during production. It actively removes carbon from the atmosphere. A hempcrete home is a carbon sink. It gets better for the climate the longer it stands. There is no other building material currently in widespread use that can make that claim. People build with hempcrete because it performs extraordinarily well across multiple dimensions simultaneously, and because the future it points toward A building industry that removes carbon rather than emitting it is worth being a part of. Hempcrete regulates moisture brilliantly, which means it naturally resists mold. The lime binder creates an environment that insects and rodents avoid, naturally pest resistant. It doesn't support combustion readily, naturally fire resistant. And the lime continues to mineralize over time, meaning hempcrete walls actually get harder and stronger the older they get. The wall literally improves with age. Important to know, hempcrete is not structurally load-bearing on its own. It requires a structural frame, typically timber, to carry the roof and floor loads. The hempcrete wraps around and between the frame, acting as insulation, thermal mass, and finished wall surface simultaneously. Hempcrete sits at the premium end of natural building costs right now, primarily because the supply chain in North America is still maturing. Hemp growing was federally illegal in the United States until the 2018 Farm Bill changed that. The industry is young and the infrastructure is still being built. Those costs will come down significantly over the next decade. Getting in early means getting access to something that will be much more mainstream and much more affordable soon. The finished result looks completely normal, contemporary, refined. Nothing about it announces what it's made from. A home that sequesters carbon, resists moisture, pests, and fire, and gets stronger every year, that looks like any other well-designed house from the outside. It feels like cheating in the best possible way. So, which one is right for you? If you're in a hot, dry climate, the American Southwest, Southern Europe, North Africa, Adobe, rammed earth, and Earthship construction are the best tested options in history. The thermal mass principle was essentially developed for these climates. Thousands of years of evidence back them up. In temperate, moderately wet climates, much of the US, UK, and Northern Europe, straw bale, cob, hempcrete, and reclaimed timber are strong contenders. The moisture considerations are manageable with good design. The insulation performance becomes a major advantage. For urban or suburban sites where building codes are more rigorous, container homes, hempcrete, and reclaimed timber integrate most easily with conventional permitting processes. If budget is the primary driver and you're willing to invest your own labor, cob, pallet wood, straw bale, and Adobe can be built for a fraction of conventional construction cost. The investment is time and effort, not materials. If you're thinking about building that performs over 50 or 100 years with minimal maintenance, rammed earth, hempcrete, and Adobe are in a category of their own. The upfront cost is higher, the lifetime cost is dramatically lower. Really, there's no wrong answer here. The right build is the one that fits your climate, your skills, your site, and your goals. Most of these methods have been tested by real people in real conditions for decades, some for centuries. They work. The question is just which one works for you. 10 homes, 10 completely different answers to the same question. What if we built differently? Maybe sustainable living isn't about going backward. It isn't about roughing it. It isn't about giving things up. Maybe it's about building smarter, with more intention, more knowledge, and a willingness to look at the materials around us and ask, what else could they be? Because the future of housing doesn't have to come from global supply chains and materials we've never touched and buildings designed to last 20 years before they need replacing. It might come from rethinking the value of what's already around us, from choosing materials for what they do over 50 years, not what they cost this week, from building things meant to outlast us. Welcome to Terra Common. Every week on this channel, we go deeper into the building methods, the systems, and the ideas shaping how people live closer to the earth. We cover the real costs, the real challenges, and the results that are actually possible. If this video gave you something, please subscribe. Drop a comment and tell me which of those 10 homes you'd actually want to build. I read every single one, and those conversations are often where the next video comes from. Everything we referenced today is linked below in the description, and I'll see you in the next one.